So now I'm going to talk to you about the intrinsic pathway that leads to coagulation. And the intrinsic pathway begins with damage just to the blood vessel, so it's within the blood vessel wall. And it begins when a clotting factor, factor 12, comes into contact with collagen. In a healthy blood vessel, the wall is lined with simple squamous endothelial tissue, and the collagen fiber within the wall wouldn't be in contact with anything in the blood. If there's damage, then the collagen becomes exposed, and that's when factor 12 will come into contact with it. And that simple contact between the clotting factor and the collagen will lead to the activation of factor 12. Factor 12 will then activate, it'll catalyze the activation of factor 11. Factor 11, once it's become activated, it's now a functional enzyme, and it's going to catalyze the next reaction in which an inactive form of factor 9 is converted to active factor 9, which again is an enzyme. Factor 9 will catalyze the activation of factor 8 into active factor 8. And this is going to catalyze the conversion of inactive factor 10 into active factor 10. And at this point, it's going to look a lot like what we talked about in the previous video, in which factor 10, once it is activated, will combine with factor 5 to form prothrombinase. Prothrombinase is an enzyme that catalyzes the conversion of prothrombin to thrombin. And then thrombin is an enzyme that will catalyze the conversion of fibrinogen, a soluble protein, into fibrin, which is an insoluble protein that strengthens a platelet plug and forms the clot. And so this intrinsic pathway actually has several more steps than the extrinsic pathway. But it's pretty straightforward, where we have a kind of domino effect or a cascade in which one step activates the next step, which activates the next step and activates the next step, and so on. Calcium is required for a couple of these stages, the conversion of factor 9 to the active form, and then the conversion of factor 10 to the active form. And so this is the intrinsic pathway. Another way in which the intrinsic pathway is different from the extrinsic pathway is that this cascade of events takes longer than the extrinsic pathway cascade of events. Part of that is due to the fact that we have more steps, but this is also a slower pathway. So that is the intrinsic pathway that leads to the formation of a stable blood clot from damage that is exclusively within the blood vessel wall.